prostate glands, therefore named as prostaglandins. Structure of prostaglandin. Structure of prostaglandin. Prostaglandins are unsaturated carboxylic acids containing 20 carbon atoms. The basic skeleton of this prostaglandins is prostanoic acid containing five-membered ring fused to positive carbon chain in 1,2 position. So here, cyclohexane having two carbon side chains with the 20 number of carbon atoms with the carboxylic acid as a function group. Classification of prostaglandins. The prostaglandins are classified into A to H. PG1, PGA, PGB, PGC, PGE, PGD, PGE, PGF, PGG, PGH, PGA, PGR, based on the presence of function groups on cyclohexane ring, based on the presence of cyclohexane ring. In prostaglandin A, that is a alpha beta unsaturated cyclopentone ring is there. PGB, alpha beta unsaturated cyclopentanone is there. In PGA, double bond is left side. In PGB, double bond is right side. In PGC, beta gamma unsaturated cyclopentanone is there. In PGD, and hydroxy cyclopentanone is there. PGE and hydroxy cyclopentanone is there. And in PGF, dihydroxy cyclopentanone is there. Dihydroxy cyclopentanone is there. And in so these lot of are there in our syllabus. So these are the prostaglandins, classification of these prostaglandins, and physiological activity of prostaglandins. Yeah, these are the physiological activity of prostaglandins. PG2 receptor 9 EP1 and distribution and smooth and muscle and fibril and transduction signal and effects. So these are the physiological activity of prostaglandins. So next we are going to, in our syllabus PG1, PG1 alpha, PG2 alpha, PG3 alpha is there. Now we are going to discussing structural institution of PG1 alpha. In our syllabus, so PG1 alpha, PG2 alpha, PG3 alpha is there. Now we are going to discussing structural institution of PG1 alpha. The molecular formula of PG1 alpha is C20. It's 32O5. Thus, PG1 alpha undergo acylation with in presence of pyridine, then gives diacyl derivative of PG1 alpha. That indicates two hydroxy groups are present. Two hydroxy groups are present. When this PG1 alpha react with hydroxylamine, hydrogen chloride, then gives an AXM derivative that indicates there is a carbonyl function group is present. This PG1 alpha gives a negative test which shifts reagent towards failing reagent that indicates that carbonyl compound is conformed as an aldehyde. When PG1 alpha reacting with one mole of hydrogen, then gives dihydro PG1 alpha will be formation takes place that indicates when double bond is present in PG1 alpha. When PG1 alpha undergoes esterification with the diazomethane, then forms a monomethyl ester of PG1 alpha indicates there is a one carboxylic acid function group is present. But the PG1 alpha in IR spectrum gives a strong band at uh, strong band at 1733 centimeter inverse in IR spectrum. That indicates there is a five-membered ring with a cyclic ketone structure is present. So the structure of PG1 alpha was deduced from the following degradation reactions. So degradation one, when PG1 alpha under reacting with the dilute NaOH undergo loss of water. Dilute NaOH undergo loss of water molecule, then forms isomerized dehydrated PG1 alpha. This isomerized dehydrated PG1 alpha undergo acylation with stickanated in presence of pyridine, then gives monoacyl dehydrated PG1 alpha will be formation takes place. This monoacyl dehydrated PG1 alpha undergo esterification with diazomethane, then forms monomethyl ester derivative will formation takes place. This monomethyl ester derivative undergo ozonolysis, then gives four compounds, that is monomethyl subarate, succinic acid, carbon dioxide, and 2-hydroxyheptanoic acid formation takes place. And the formation of these the formation of these structures in these four compounds indicates the structure of PG1 alpha is confirmed as a below. So that is in this PG1 alpha one double bond is there, and one ketone is there, two hydroxy group is there, one carboxylic acid group is there, and 20 number of carbon atoms are there. So so the structure degradation explanation experiment degradation experiment evidence for evidence are when that when reacting dilute H2S when reacting dilute NaOH undergo loss of water molecule, then forms isomerized dehydrated PG1 alpha. This isomerized dehydrated PG1 alpha undergo acylation. That OH group undergo acylation takes place. Then methylation to diazomethane, then ozonolysis, then gives four compounds. One is methyl monomethyl subarate, succinic acid, diazoxyheptanoic acid, and carbon dioxide. This is the evidence for the formation of that one is takes place. And this the stereochemical structure of PG1 alpha, that is at 11th carbon, at 11th carbon hydroxy group is alpha, at 15th carbon hydroxy group is alpha, and double bond between 7 and the bond between C7 C8 is alpha, and the bond between C12 C13 is beta, and the double bond between C13 C14 is trans. Next one is structural elucidation of PG2 alpha. Structural elucidation of PG2 alpha. The molecular formula of PG2 alpha is C20H32O5. Molecular formula of PG2 alpha is C20H32O5. When this PG2 alpha undergo acylation with acetic anhydride, then forms a diester derivative of PG2 alpha, then indicates two hydroxy groups are present. When this PG2 alpha reacting with hydroxylamine hydrogen chloride, then forms monooxime derivative of PG2 alpha. That indicates one carbonyl group is present. This PG2 alpha under gives negative test with the shifts tolerance failings that indicates the carbonyl group is confirmed as a ketone. When this PG2 alpha undergoes esterification, they pumps monomethyl ester of ester derivative of PG2 alpha. That indicates one carboxylic acid function is present in PG2 alpha. And this PG2 alpha undergo catalytic hydrogenation with platinum produces dihydroderivative of PG1 alpha or tetrahydroderivative of PG2 alpha. Hence, it indicates that PG2 alpha is having two double bonds are present. Next, degradation reactions. And this in IA spectrum, PG2 alpha gives a strong bond at 1733 centimeter, indicates there is a cyclic ketone functional group is present. So next, the following degradation experiments confirmed as the structure. So when PG2 alpha undergo dilute NaOH undergo loss of water molecule, then forms isomerized dehydrated PG2 alpha. This isomerized dehydrated PG2 alpha undergo acylation, then forms monoacyl derivative of PG2 alpha. This monoacyl derivative of PG2 alpha undergo react with diazomethane, then forms monomethyl ester of monomethyl ester derivative will be formation takes place. This monomethyl ester derivative undergoes analysis, there forms of five compounds. One is methyl glutarate, malic acid, succinic acid, carbon dioxide, 2-hydroxy, heptanoic acid will be formation takes place. So the degradation studies suggested that the degradation the degradation study suggested that the following structure of the following is the structure of PG2 alpha. That is, in this case, here two hydroxy groups are there, two double bonds are there, one carboxylic acid, one aldehyde is there. Okay, and the evidence for the degradation reactions is when that molecule undergo undergo isomerization, then forms isomerized dehydrated Pg2 alpha. This isomerized dehydrated Pg2 alpha undergo acylation, then forms monoacyl dehydrated Pg2 alpha. This compound undergoes analysis, then gives five compounds, that is glutarate, malic acid, succinic acid, carbon dioxide, 2-hydroxy, nitric acid will be formation takes place. So this is the structure of conformed as a PG2 alpha. Next one is structure elicitation of PG3 alpha. When molecular formula of PG3 alpha is C20 is 30O5, molecular formula of PG2 alpha is C20 is 30O5. The PG3 alpha react with acetic anhydride in presence of uh, B-spreading, then forms a diacid derivative of PG3 alpha that indicates two hydroxy groups are present. This PG2 alpha reacting with hydroxylamine hydrogen chloride then forms oxygen derivative that indicates there is a carbonyl group is present. This PG2 alpha, PG3 alpha reacting with the when reacting with the shift reagent, valence and failings, then gives negative test that indicates that carbonyl is all conformed as a aldehyde. The when PG3 alpha reacting with esterification with diazomethane and methanol, then forms monomethyl ester that indicates one carboxylic acid group is present. When this PG3 alpha reacting with three equivalents of hydrogens in presence of platinum, then gives hexahydro derivative of PG3 alpha that indicates three double bonds are present in PG3 alpha. In AR spectrum, shows a strong band at 1733 centimeter indicates there is a cyclic pentanone ring is present. Next, degradation reactions. When PG3 alpha react with a diluted NaOH, then forms isomerized dehydrated PG3 alpha. This isomerized dehydrated PG3 alpha under acylation they gives monoacyl derivative of dehydrated PG3 alpha. This compound undergoes esterification with diazomethane and methanol, then forms monomethyl ester of PG3 alpha. This compound undergo hydrolysis in presence of ozone, then gives then gives six compounds. So that is methyl glutarate, malanoic acid, succinic acid, carbon dioxide, 2-hydroxy succinic acid, propanoic acid product will be formation takes place. And NMR spectrum of PG3 alpha in a wolfine region, 4.32 to 4.8 delta. The two double bonds are observed in 1:2 ratio. The first the first double bond with the J17H is due to the C1 C13 C14 trans, and the double bond second double bond is uh, two double bonds of cis at 13 C13 C14 and C17 C18. The J value is 2 to 12 edges. Therefore, the structure of PG3 alpha is this one is confirmed in this two hydroxy group, one carboxylic acid and one carbonyl group is present. So, evidence for degradation reactions. undergo loss of water molecule, then forms isomerized dehydrated PG3 alpha under acylation with ester-connected pyridine, then gives monoacyl derivative of PG3 alpha, diazomethane, methyl, reacting with diazomethane when diazomethane forms monomethyl ester, monomethyl ether state derivatives. Under ozonolysis, they gives methyl glutaric acid and malonic acid, carbon dioxide, through succinic acid, and propanolic acid. So therefore, the structure of PG3 alpha is confirmed as this one. So next, we are going to see prostaglandins. When this cyclopentanone ring, when the cyc, when cyclopentadiene 1,4,1,3 cyclopentadiene reacting with titanium. So methylation takes place at active methylene group, then followed by reacting with chloromethoxy methyl ether, then loss of titanium chloride, then forms so alkylation takes place at active methylene group. This compound undergo Diels order reaction with alpha chloro ecrylene. So then forms as substituted bicyclic pentane derivative. The cyclic pentane derivative undergo hydrolysis, then gives that cyano alpha chlorocyano compound that carbon converted into ketone. Next, it is reacting with metachloroperbenzoic acid. They undergo Bates-Berry oxidation, so insertion of oxygen with the more substitution side, then followed by opening of the this cyclic ester with KOH and water, then hydrolysis, then forms a cyclopentene ring. So in this cyclopentene ring, hydroxy group and carboxyl group and methoxy is there. So this compound undergo adenation with potassium iodide and iodine with respect to hydroxy group. So adenation takes place and followed by ring formation takes place. So then reacting with protection of hydroxy group as a ethers in presence of alkyl halide. So base then followed by deprotection of iodine group, the tertiary and tertiary butyl tinnidrate, removal of hydrogen, aided by the hydrogen and reaction with the tribromoborane, that is ether is converted into alcohol. So now this alcohol are undergo Collins reagent oxidation, that is chromium trioxide and pyridine, that alcohols converted into aldehydes. When this compound undergo Wittig reaction, then gives trans double bond will be formation takes place. Undergo selective reaction with the Corey reagent. Then that ketone alpha beta unsaturated carbonyl compound. The carbonyl is converted to alcohol. That alcohol is protection with the dihydro dihydropyrene taken converted into tetrahydropyrene. When reaction with the diol H, that ester is cyclic cyclic ester or lactone is converted into aldehyde and alcohol. Now this compound simultaneously undergo Wittig reaction, then aldehyde undergo Wittig reaction, then forms two side chain with two hydroxy group. This compound undergo oxidation, deprotection followed by oxidation, then PG2 alpha. When this intermediate is under selectively undergo reduction of the cis double bond, then followed by oxidation, then gives PG1 alpha. Let's synthesis of PG3 alpha, that intermediate, what we taken that intermediate undergo um, Wittig reaction with a side chain having one double bond, then gives two trans double bond compound. Now this ketone undergo a reduction with the 4 is reagent. That alpha beta unsaturated carbonyl compound, carbonyl converted alcohol. Next, these two alcohols here again. That OR is the deep protection takes place, followed by two hydroxy groups are protected with the dihydrofuran, then come tetrahydropyrin. This tetrahyd then reacts with dibolage. So lactam is converted into all alcohols and aldehyde. Then Wittig reaction then gives deep protection of OTHP is converted to alcohol. Then oxidation gives PG3 alpha is the product of the formation takes place. So this is the biosynthesis of prostaglandins. This is a biosynthesis of prostaglandins. The biosynthesis of prostaglandin is catalyzed by the various enzymes. The biosynthesis was started from started from arachidonic acid. The steps involved in the biosynthesis of prostaglandin are summarized below. Summarized below. Then arachidonic acid when reacting with ozone, reacting with the oxygen molecule, then use Pg2 alpha, PGG2. This PGG2 undergo hydroxy oxidation, then gives PgH2, then isomerization, then gives prostaglandins of the derivative B formation takes place. PG2 alpha, PGD2 alpha, PGF2 alpha will be formation takes place. Yep. Next, we are going to discussing continuously black three heterocyclic compounds. Heterocyclic compounds. This black deals with heterocyclic compounds. It is divided into five units. So 11th unit is a 5-member tetracyclic with two heteroatoms. 12th unit is a 5-member tetracyclic with more than two heteroatoms. 13th unit is 6-member tetracyclic contains two heteroatoms, two nitrogen atoms. Same member ring 17th unit is the synthesis of pyrimidine, furan, and xanthine bases. 15th unit is 3 and 4 member heterocyclic compounds. Now, first we are going to discussing First, we are going to discussing unit 11. 5-member heterocyclic contains two heteroatoms. 5-member heterocyclic contain two heteroatoms. remember heterocyclic contain two atoms. So that examples are uh, isoxazole, oxazole, pyrazole, imidazole, isothiazole, and thiazoles. First one is isoxazole. Synthesis methods for synthesis of isoxazole. So from 1 comma 2 diketones and hydroxylamine. When 1,3 dicarbonyl compounds reacting with hydroxylamine, then that in this hydroxylamine, that NH2 is condensed with one of the carbonyl, then forms ox- oxime will be formation takes place. This oxime involves in the that OH involves in the addition to the carbonyl compound and finally elimination of water molecule, then forms isoxazole product will be formation takes place. So some another examples are here mentioned. Next one is so when alpha beta unsaturated carbonyl compound and hydroxylamide. When this alpha beta unsaturated carbonyl compound reacting with the hydroxylamide undergo Michael addition type addition takes place. Addition NH2 of hydroxylamine group addition at beta position of alpha beta unsaturated carbonyl compound. Simultaneously addition of that OH group to the carbonyl compound, elimination of water molecule, then gives isoxazole product will be formation takes place. Next example is from aryl aryl alkyl ketone. From aryl alkyl ketone, when this aryl alkyl ketone reacting with hydroxylamine, aryl alkyl ketone reacting with hydroxylamine, then oximes will be formation takes place when this oximes reacting with the base abstract the proton from uh, uh, abstract the proton from alkyl group and OH group. Then di two negative charges are formation takes place at alkyl group and OH group. When this compound reacting with ester, one of the alkyl group negative charge reacting with replace the ethoxy group and negative charge on or oxygen is attacked at carbonyl carbon, then forms uh, a simultaneous elimination of water molecule, then form the isoxazole product will be formation takes place. Then nitrile oxide. From nitrile oxide, when nitrile oxide reacting with alkyne, then undergo 1 comma 3 dipolar addition reaction, and then forms isoxazole product will be formation takes place. Next one is the reactions. Isoxazole is a weak base. It is undergo electrophilic substitution reaction more readily than that of pyridine and but less than that of furan. Electrophilic substitution reactions. Because of the electron withdrawing group nature of pyridine nitrogen, isoxazole undergo few. Isoxazole undergo few. Isoxazole undergo few uh, electrophilic substitution reactions. Electrophilic substitution reactions takes place at C4 position, such as bromination with NBS and nitration with HNO3 H2SO4 and sulfonation with fuming H2SO4, chlorination with chlorine eating. Nucleophilic substitution reactions. So if halogen atom at fifth position, that halogen atom is replaced by the amines group negative nucleophiles, such as amines or hydroxy groups. So in this 5 halo isoxazole reacting with the primary amine, that halogen is replaced by primary amines, then gives secondary amines as the product. And in presence of strong base, opening the ring system takes place when isoxazole reacting with the strong base like sodium hydroxide, potassium hydroxide. Base subtract the from the second position of nitrogen and negative second position C third position, that means C3 carbon, third position. So base negative charge will be forms on C3 position that is involves in the opening of the ring and forms beta ketone nitrile product. Next one deals at the reaction when this isoxazole reacting with the uh, dyene. This isoxazole act as a dienophile. When reacting with dienophile, adaptive formation takes place. Next, thermal rearrangement. In this thermal rearrangement, isoxazole is converted into oxazole. Isoxazole is converted into oxazole. Some important isoxazoles. These isoxazole derivatives are act as a antibacterial and herbicides, non-allergistic and hypoglycemia agents. Oxazoles. So general method for synthesis of oxazole. So in this oxazole is a pi-membered ring, unsaturated pi-membered ring. So that position of two nitrogen and oxygen atom is there. The position of nitrogen and oxygen atom are 1,3 position. When the general method for synthesis of oxazole. So method for synthesis of oxazole, Robinson-Grabiel synthesis. First one is Robinson-Grabiel synthesis. In this Robinson-Grabiel synthesis, uh, alpha acyl ketone, alpha acyl ketone, alpha acyl amino ketone, alpha acyl amino ketone. So, and in presence of acid medium undergoes cyclization, then gives oxazole product will be formation takes place. Second method is amino ketone reacting with amino ester. Amino ketone reacting with amino ester in presence of glycolic acid. Then elimination of this ethanol, then give oxazole product. In from isocyanates, when alkyl isocyanates reacting with the n-butyl lithium, they subtract the proton from positive charge nitrogen position, and this is involved reacting with acid chloride. So this positive negative charge on positive charge nitrogen involves in the elimination of chlorine. So then it is here ketone will be formation that keto carbonyl reacting with the 1,3 addition reaction with the uh, nitrile, then gives oxygen product. Next one is from diazo compounds and nitriles. When alpha diazo aldehydes ester, alpha diazo aldehyde and ester reacting with the nitriles, then first forms carbon intermediate. This carbon intermediate reacting with the nitrile undergo one gamma 3 diproduction reaction. They forms oxyol product. This oxygen reactivity. Oxyolars are weak base. Their salts are unstable. Electrophilic substitution reactions of oxyol. Electrophilic substitution reactions of oxyol takes place C by position. These are electrophilic substitution reaction with the NBS bromination nitration with and mercuration. Nucleophilic substitution reaction. Reaction with nucleophilic reagent. If halogen atom at the second position, the nucleophile displace the halogen atoms. So in the here 2-chlorooxazole, when reacting with aniline, the elimination of HCl then forms a secondary amine product will be formation takes place. So in here 2-methyl 4,5 diphenyl oxazole reacting with amine then forms 2-methyl 4,5 diphenyl imidazole product will be formation takes place. That means oxazole to imidazole will be formation. When metallation of oxazole takes place at C2 position, metal reacting with phenyl lithium base subtract the proton from second position of proton. Metallation takes place second position. This metallation involves in the opening of the ring. Next, Diels-Alder reaction. In this Diels-Alder reaction, oxazole act as a diene, dialkyl stellene act as a dienophile, undergo Diels-Alder reaction. The elimination of alkyl cyanide then gives furan derivative will be formation takes place. Some of the important of oxazoles. These oxazole derivatives are act as a antibacterial, antiviral, anti-inflammatory, and analgesic properties. Pyrozoles. Methods for synthesis of pyrozole. When one from by condensation of 1,3-dicarbonyl compound with hydrogen. When 1,3-dicarbonyl compound reacting with hydrogen hydrate, then forms pyrozole derivative. When alpha beta acetylene compound with hydrogen, when alpha beta acetylene compound reacting with hydrogen, then form first condensation with the carbonyl carbon and hydrogen. Imine formation takes place. This imine of hydrogen will be formation takes place. This hydrogen undergo Michael addition reaction, then forms then gives it is offered imidazole product will be formation takes place. Pyrozole will formation takes place. Reactions. Free NH unsymmetrical pyrozole exists two isomerisms. There's 3-methyl pyrozole, 4-methyl pyrozole. That indicates third position and fifth position are in pyrozole are same. In substitution, pyrozole reacting with alkylation with alkyl halide or acyl groups, the NH free NH undergo alkylation or acylation takes place. Next, electrophilic substitution reaction of pyrozole. Pyrozole undergo electrophilic substitution reaction with C4 position. So these are some examples for electrophilic substitution reactions of pyrozoles: nitration, bromination, chlorination, sulfonation, nucleophilic displacement reaction, nucleophilic reactions. If a nucleophile attack it, nucleophilic reaction, nucleophile attack at either C3 or C5 position in pyrazole. If nucleophile and reaction with metallation takes place at the third position. When metal react with the third position, base of metal react with third position, then followed by opening the ring takes place. And these are some of the photochemical arrangements. Pyrozole is converted to imidazole via formation of azirine intermediate. So some of the natural occurring and biological active compounds of pyrozoles. So these are the natural occurring biological active compounds act as a anti-inflammatory, antiviral, hyper, antipyretic, and has long bacteriostatic activity. Then imidazoles. In the imidazoles, two nitrogen atoms are present in unsymmetrical by ring at 1,3 position. Synthesis by one is Rajskrick synthesis. 1 comma 2 dicarbonyl compounds reacting to excess of ammonia, then all the kinds of aldehyde, then gives imidazole product will be formation takes place. When this is a mechanism involved in this mechanic reaction synthesis. So from second one is from alpha haloketone and amidines. When alpha haloketone or that is alpha haloketones reacting with amidines by loss of water molecule and HBr, then gives imidazole product will be formation takes place. So then alpha hydroxyketone also involved in the same reactant amidines, then gives imidazole is product will be formation takes place. And properties: NH free NH imidazole as act as amphoteric. It is a tautomeric nature it shows. Then salt formation reaction with acids react with NH group. Free NH undergo alkylation and Michael addition type reactions and manage reaction. Reaction at second position. When metallation takes place at second position, electrophilic substitution reaction at C4 or C5 position, such as nitration, sulfonation, and bromination and alkylation, etc. Nucleophilic displacement reaction. If halogen atom at second position, nucleophile displacement takes place. Halogen atom at second position, nucleophile displacement takes place. In this, two bromomidazole reacting with the piperidine, then bromine, that halogen atom is displaced by secondary amines. Some of the important imidazole derivatives act as an antibiotic, anti antifungal, and and act as some of the studies. One of the essential amino acid contain imidazole mighty. Next one is thiazoles, isothiazoles. Methods of isothiazoles. General method for synthesis of isothiazoles. So when enol ester reacting with when enol ester reacting with nitrile dioxide, then followed by loss of acetic acid, then gives isothiazole product will be formation takes place. Get some of the reactions with wolfine and sulfur dioxide ammonia involved in the formation of mm, isothiazoles. Next reactions, electrophilic substitution reactions. Isothiazole electrophilic substitution reaction takes place at C4 position, such as the nitration. I am taking here example in nitration. Nucleophilic reaction with nucleophilic reagent. Halogenate 6 fifth position and undergo a nucleophilic displacement reaction. And metallation takes place at the C5 position. And when reacting with alkyl lithium, metallation takes place fifth position. When this negative charge at fifth position involves in the bromination alkyl halide. And this, if fifth position is blocked by different groups, metallation takes place at third position. This third position metallation involves in the opening of the ring. And some of the now here photochemical isomerization, iso isothiazole convert into thiazoles, 3-methyl isothiazole to 3 2-methyl thiazole. And some of the important of isothiazole derivatives act as a saccharin containing isothiazole moiety, and sulfamazole is antibiotics. So some of the fungicides are there here. Next one is thiazoles. General method for synthesis of thiazoles. In this thiazoles, unsaturated fiber buttering with sulfur and nitrogen atom at 1,5 position. General method for thiazole from alpha halo compound. In this alpha halo compound reacting with thiamide, then reacting with the ketone, then forms thiazole product will be formation takes place. Next one is alpha halo ketone reacting with ammonium salt under reflection ethanol, then forms thiazole. Next, grabial synthesis, diacyl amino ketone, alpha acyl amino ketone, reacting with P2 of S5 upon heating, and that is alpha thioacyl amino ketone will be formation takes place. It is reacting with loss of water molecule, then forms thiazole product will be formation takes place. Next one is reactions. Thiazole forms crystalline salts with strong acids, quaternary salts formation with alkyl halide, and electrophilic substitution reaction at C5 position, such as bromination, halomercuration, sulfonation, and nitration. Nitration is not possible at this case. And halogen atom at second position undergo nucleophilic displacement reaction, such as phenyl sulfide, phenyl thiophenol, and methoxide displace the halogen atom at second position. Thiazoles and unsubstituted in second position react with the sodiamide in liquid ammonia to form 2-amino thiazole. Some of the biological important of thiojoles. Vitamin B1. Thiamine is containing a thiazole, vitamin B1. Penicillin is the thiazole ring is present.